FK, refers to the process in robotics and computer graphics of calculating the position and orientation of a robot's end effector, like a robotic arm or hand, given the angles or positions of its joints. It is one of the fundamental problems in the kinematics of mechanisms, particularly in robotics. Joint parameters. FK involves a series of joints connected by links, and each joint is typically controlled by an angular, rotational, or linear, translational parameter. Links, the rigid segments between joints. End effector, the final link of the chain, typically the part that interacts with the environment. Given the joint angles and the lengths of the links, FK determines the position and orientation of the end effector in space. This is done by multiplying the transformation matrices corresponding to each joint/link. The transformations account for the rotation and translation at each joint in the kinematic chain. Robotics. To control a robotic arm, FK helps in determining where the arm will be positioned when certain joint angles are applied. Animation and graphics, used to animate limbs or objects in computer-generated scenes. 3D printing. FK is important in controlling the movement of robotic arms that construct 3D printed objects. Inverse kinematics, IK, is the reverse process of forward kinematics. In robotics and animation, IK is used to determine the joint parameters, angles or positions, necessary to achieve a desired position and orientation of the end effector. Essentially, instead of computing where the end effector will be based on joint angles, as in forward kinematics, IK solves for the joint configurations required to place the end effector at a specific location. End effector position. IK starts with the desired position and orientation of the end effector, e.g., where you want a robotic hand or arm to be in space. Joint angles. It then calculates the angles or positions of the joints needed to achieve that end effector position. Degrees of freedom. DF, the number of joints or variables that can be controlled independently in the system. In IK, the number of DOS can affect the complexity of the solution. Robotics. In robotic arms, IK allows precise positioning of the end effector to interact with objects or perform tasks, e.g., grasping, welding. Computer graphics and animation. IK is commonly used to animate character limbs to follow a target, such as making a character's hand touch a specific point in space. Medical devices. In surgical robots, IK is used to control the positioning of robotic instruments during operations. Let's watch a video demonstrating IK. Let's reflect on what we have learned so far.